Hi everyone, so today we're gonna deep a bit more into Pandas data frames. So let's start, as usual, do Anaconda PowerShell prompt. I'm going to select my Conda environment, which was Python 20, actually PyProj env. Then I'm going to go to my folder, which was GitHub repos and Python repo, and then I'm going to install StarJupyter So as said before, I want to open it in Google Chrome, so I copy the URL here instead. Alright, so let's actually create a new notebook and let's call it Pandas and a bit of NumPy. So Pandas and NumPys are two libraries. When you install Panda, you also install NumPy. Uh, they are dependent on each other, like dependencies. So Pandas is built on top of NumPy. So if I do conda list to see what are the packages installed in this environment, I should be able to see NumPy as well. So NumPy get installed with Pandas when you install Pandas. Okay, so NumPy also is a package for data manipulation. It is used for big data, for data analysis, and it adds some features to Python regular types like list and tuples and all that. So just as usual, uh, we import these two. So you can run it with this or shift and enter. So this one you see a lot is just like customary. People use it. They use import numpy as np. It's just easier. So when you do import numpy as np, it means that you can use this np name here in your code instead. So if I do import numpy only, if I want to call this package, I have to call numpy dot something, okay? But to make it easier, we just make it np and pd, then we can do np dot something and pd dot something, okay? So actually, let's go and start by Pandas series. So we have a type in Pandas called Pandas series. If I create one, let's say I just say Pandas series, and I can just give it a list in Python. 1, 3, x minus 9, and it creates a series for me. So series in Pandas are a fundamental type in Panda. So all of the data frames, they have multiple series, so we're gonna talk about it. So here, of course, I can assign a name to it like before and just call that name if I want. Okay, let's create another series as well. I call it series 2, then I make it something interesting. So instead of text, I put np.nan. np is from numpy, and nan, like nan value, is just non-defined data that you don't have. So it happens a lot that when your CSV doesn't have anything, or when you're coding and your data is missing, you get NaN in your series and your data frame. It means that your data is not there, it is missing. Okay, so let's go a bit through some other data frames. Um, let me see what are the best topics to cover. So another topic that I can just show is to how easily you can, using a NumPy array, create a Pandas data frame. So let's come here, you see here, I call date range. Let's give it a date like 2020 001, and then you give it a period 8. So here you see how can I create a datetime index for a given date for 8 periods. So 1, 2, 3, 4, 5, 6, 7, 8. So it starts it starts from the date that I give it, and just by default go like 1 day up to the 8th. So it's just that's the daytime. And now that we have this daytime index, let's actually create something for the data frame. So let's create our data frame. For the data of this data frame, I just want to use random data. Okay, so I use NumPy that has some built-in possibilities for random data. So if I do Shift and Tab on this, it's gonna explain to me what is it doing. So it's like a random module. This is what it does. It's random number generation, and we want to use randin, which is rand integer, which if you want to get more info, so here it doesn't have docstring, it doesn't show here, you can go to documentation. So what it does basically, let me show you for one. So if I do something, oh sorry, rand n, not randin, it's gonna give me an array, a numpy array with the dimension that you gave it. So you wanted to have 10 rows, so here 10 rows and 3 columns. Okay, so it's pretty straightforward. What if you want 3 rows and 3 columns? It would be like a matrix. Okay, so here I want to create a Panda data frame. For the data I pass a random one, so I want to use this date index. So here it was 8 date index, right? This is what we did. So let's say I want 8 rows and I want 4 columns. Okay, so the first one, if I do Shift and Tab, the first one is data. So either you can pass it as first argument, or you can make it keyword argument, like say data equal. This is the concept that we talked, positional and keyword arguments. So I'm gonna specify it for now. So I say data equals this, and even if I don't specify it, because the first one is data, it's gonna pick it as the data. Okay, so about the index, I'm gonna give it these dates that I created at the top. So index is like the first column of your data frame. It's not the first column, it's the indices, but it's like index of, like you can say it's like defining what each row is doing, or what is the index for each row. So let's Shift and Tab and see what else we have. We have columns, so we have to specify what are the columns that I have. So columns. So with our random data, you see that we have 8 rows, 4 columns. So let's actually pass 4 columns. So I call A, B, C, D. So when I enter, I have a nice data frame. I have 8 rows, which read from this date that I created at the top. Then I use a NumPy array, NumPy random array, to generate some data, and then I gave it columns. So here we talked about random array that NumPy can do. And let's actually use a trick for the column. So to make it simpler, if I do a string like this, A, B, C, D, Actually, so if I use the data split method, I can split the string by some value. So it could be a space, or if I want to uh, separate them with a comma, I can specify comma here, and it's gonna give me a list of ABCD. It's gonna make them split. So by default, the value here is a space. So if I do Shift and Tab on this split, let's see if Jupyter gives it to me. Split, Shift and Tab, nope. Sometimes it doesn't like load the text string, but you can see it in the documentation that the default is a space. And so if I do this, it's not gonna give it to me, it's gonna give me just one string. But then if I tell it no, I wanna split them by a comma, it's gonna give me this. Here instead of comma, if it is like this, and I say okay, split them, it's gonna be the same. Okay, so here instead of specifying columns like this, I can make it easier and just say my columns are ABCD and then split it. So it means that, and don't forget to call this with open and close parentheses. So it's gonna give you a list as we discussed here, and then you can run it here. So if I run it, the same result. Okay, and you see that these are random values, so each time I run it, the values are gonna change. So for now it is random, but it's possible to specify some seeds for it so that the random data doesn't change. For now, it's not important for us. So we created a data frame easily with some random data, and you can see that it's very powerful, right? You can create random data, create a big data frame, create your indices with datetime and all that. So another common way of creating a data frame is by passing a dictionary. So if I do pd.dataframe and pay attention, then D and F are both capital parentheses, I can pass some dictionary. So let me prepare my dictionary at the top first. My dictionary. Remember, dictionary in Python, they have a key and then colon, and they have a value. So if I say something like this, and then another key, and something like this. Now if I say, okay, create a data frame with this dictionary, as I told you, when we pass it as the first argument, it's gonna treat it as data. So if I do like this or do like this, no difference. So it's gonna create a data frame for me. So you see that the first one is my columns, the keys, and the values I pass as a list, so that it's 1, 2, 3 and str something. So the length of this should be both 3. So if I pass something like 90, it's gonna give me error because the arrays must be all the same length. The first one is 4, the second was 3, so it doesn't understand it. So it has to be the same length to give you a data frame. So let's actually play a bit more with this. Let's use some builds. So here I built my dictionary and passed my dictionary to this, right? So let's actually use this Python data frame built-in functionality and pass something here that I'm gonna talk to you about it. It looks like a dictionary, and it's like a dictionary in Python, but we are also using some functionalities of Pandas. So first of all, one important thing to tell you, when you have open and close parentheses here, and when you have brackets, it doesn't matter if you go to next line. So Python is not gonna parse the space, the new line. So what I mean is that I can write all of my code in a single line, or I can go to the next line and write my code here. Panda and in general Python is not gonna complain. But if you don't have parentheses, it's gonna complain. So let's say, for example, if you have a uh, if you have something like this and you want to specify a tuple, you can make it like this. Then specify the rest here and then go next line and specify 67. No complaint. But if you have all in one line and you don't, and sorry, if you don't have any parentheses or brackets, you cannot just jump line and go next line, or your code is gonna get confused. Just have that in mind. So I'm going to say my key is gonna remain a value, so I call it B. Then for B, I'm gonna use timestamp, the timestamp class in the Pandas. So this is going to give me a timestamp from a string. So I call it like 2020 or something like this. Then so here for the C, I'm going to create, so we want to go a bit more involved and create more stuff. We talked about the series, right? So we're creating a series here. Let's create an index for it. Range of 4. So we discussed before, range give you 0 to 4, list make it a list. We talked about that, so it's like a review for you as well. Then let's go to another column. I just want you, so none of this is anything like magical, like something that you can get. It's just piece by piece. So each of them, so if you don't understand each of it, you just come here and copy paste this and see what it gives you. So you say, okay, I don't know what is this guy doing. I just come here, copy paste here, say, okay, it gives me something like this. Okay, and then you see that one by one, it's not that complicated. So we are creating a NumPy array here. So NumPy array, just think of it, it's similar to list in Python, but it gives it more functionalities. It is more than a list. We just keep it like this for now and then we can talk about it later. So I am trying to create 4 rows. So here I'm specifying range of 4 here I'm specifying an array, and here you see that so this one and this one, I'm just passing only one value, and I just want to tell Pandas to use the same value for all of the rows. So I'm gonna explain a bit more after this. And then I'm gonna use the categorical one, and I say str1 test Pandas. So again, it's just, so let's see if you're wondering here. So it is gonna give us a category like a list of 4 objects. Okay, so we're just trying to touch different classes that it provides for us. And then that's all. I can make another number if I want it to be fixed for all of them, and this one, let's say fixed string, or string for all of those. Don't forget the comma. after each of them. So it is key value, key value. Now if I enter, boom, I have a new data frame. So let me explain a bit on this. So here we said create a data frame. We said this is the key and these are the values. If you remember, we talked about it a bit before in how bokeh parse the data. So when you're passing only one and it's not a list, you're telling it to use it for all the rows. But when you're passing a list, you're specifying one by one. So for example here, so when you say 3 and it is like the index is 4, again this 3 is fixed. So it will be 3 for everything. Again, when you say 3 multiplied by 4, so here, when I say 3 and you multiply it by 4, it means that give me 4 of those. So it is again fixed. But for example, if I make this a list like this, it will be different. 1, 2, 4, 0. You see? And by the way, here you don't have to pass it as a NumPy array. It can be a list. I just want to show you that we have also NumPy array. So NumPy array adds some functionalities to a Python list, kind of, and you can search it, but we might also talk about it later. It adds some functionalities like you can multiply values or extend the NumPy array more than a list and play with the data better. Here was categorical. Again, this Panda gives you Panda categories, and you could still don't use this and pass a string. The difference doesn't show here, but you see this in different applications and all that. So it is good to know that PD categorical is going to give you categories of data, like categories based on Pandas standards. And here when we give only one value, it gives you all of it the same. Okay. So to come back to this previous one, here we created a dictionary, and then we create a dictionary and then pass it to this data frame and create a data frame. But here, let's actually try something. Instead, I'm going to define my dictionary and pass it here. So it will be like the same for this. Let's come here, show you something. So if I say A equal 20 and B equal, so that's what I wanna show you and the difference. You see, this is a dictionary, right? And this is a dictionary. So Python doesn't have this in mind, or doesn't have this rule that if you have a key and you have only one value for it, it's gonna make it the same for all the rows, right? So if in Python you have a dictionary and just you define A equals 20 and B equals a list of values, it's gonna it's gonna keep it the same, right? A will be 20 and B will be a list, no problem. But by default, in the world of Pandas, if you pass a single value for a key, but you pass a list of values for another key, so this is also single for this one, a list of values for another key, it's gonna make this for all of it. All right, so it's gonna consider that you, for example, here you are saying 12 multiplied by the number of rows, which is 4. Okay, so just have that in mind, that this rule that we discussed, that if you pass one single value, it's gonna go and populate through all of the rows. It's only for Pandas. Whereas in dictionary, Python doesn't care. You can specify whatever you want. So here, if I go out to the top, my dictionary was 1, 2, 3, B was this. I can just create a C. I say, okay, it will be a fixed value. Now if I run it, the fixed will be here. But if I, by mistake, make it a list of length 1, it's going to complain because it says, okay, you are making a list, so you are telling me that it is a list and I am defining the length for it, but this is 1, all of these 3 are 3, all of these 2, so it's going to complain. So you have to, if you want, make multiply by 3 to fix this issue. Or if it is just a fixed, just don't make it a list. Just pass it as a string or as a number, just as one argument. We discussed this, if you remember, in the bokeh as well. This is how they treat it. So it is like the same concept and the same way Panda does it. So here we created a Panda data frame. We use some of the methods in Panda for timestamp, series, array. So timestamp is a data type for time. Here it's not making much difference for us, but it's a data type and it has some features, like if you want to add minutes to the data, you want to say, okay, this is my timestamp, go 1 hour before, 1 hour after, 20 minutes after. You can easily do it. Panda series, as we said, is a type in Pandas world. Each of these rows is a Panda series. Okay, and each of these columns are a Panda series. I'm going to show you how. So let me create a name for this. I call it df2, and I'm going to call this at the bottom. So if I want to select one of these columns, I can just do A, and it's going to be like this. So this is a Panda series. So if I do type on it to see what is it, it gives me core series. Okay, so each column, and if we do that for the row as well, we're gonna discuss it later, it's gonna be series. So series, a combination and integration of series in Pandas will be a data frame. Okay, then one other thing that I wanna add here is that you might see this. So for example, let me actually add this here. So you might see data type, something like this. So you want this data type is in Pandas, and it is just to specify what is the data type of me in Pandas. So it is a float 32, like 32 byte, and then you wanna treat this as a float value. So this one also you see in some code when you wanna specify, when you're creating the data, when you're even getting the data, you wanna specify what is the type of the data that I have. Is it float? Is it integer? What is kind of the bytes for it and all that. So if you want to know what is, let's see, so this is df2. If I want to know what are the data types of this data frame, it's gonna give me by column. So the first one is integer. This one we didn't define it, but it was automatically set based on Python and the configuration I gave it. So it will be integer 64 byte. Sorry. So column B is datetime, as we specified. Column C is float 32, D integer 32. You can read on differences in 64 and in 32, 64 by 32 byte. They have differences like based on the memory that they allocate, and differences between memory allocation and the size they could have, different values they could have. E is a category, as we define Panda category. F is an int64, and G is just an object. So you see that although when we defined G as a string, and we defined the same list, these are all a string, but when we did PD categorical, it made Panda look at them as different types. So for this is category, and for the other is just an object, which for now all is good for us. We don't worry about that. So let's see, we have other data. Let's actually make a bigger data set. I'm gonna use this code before. The PD data frame, let's make it 200 rows. Let's make it 7 columns. And remember, we had some dates, so let's go and get our code for dates. So dates was here. I said period 8, so let's make it the year 200. And then we want to have 10 columns. So for now, it's A, B, C, D, F, G, H. One, two, three, four, five, 6, 7, 8, and 10. Now if I run this and I want to know my DF, I have this. I have 200 rows and 10 columns, which the index is the date and the columns are A, B, C, D up to J. So let's play with this data. So I have my data frame. So if I want to view my data, what do I do? We can use the head one, open and close parentheses, to see the head of my data frame, like the first rows of it. By default, if I do Shift and Tab, the number is 5. Means that it's gonna show me the first n rows, and the n is 5 by default. So I can, for example, make this, give me the 8 one, the first 8 one, or give me the first 2 one to specify it. But if I don't, it will be the first 5 one. So this is something good for seeing your data if you don't want it to show all of it when it is very big. We have also, so let's go to DF again. We have also tail. Tail is the opposite, so it's gonna return the last n row data, and again the default is 5. So here it's gonna show you the very last. You see your data frame, it starts from 1, it comes here. So tail shows you the last data that you want. If you want to know what is the index of your data frame, just to df.index, it shows you all the indices. This is date time that we created at the top. So you see these are the indices of your data frame. If you want to know what are the columns of my data frame, just to df.columns, and gives you the list of columns. And that's it. One important other thing is df describe. So df describe by default, it gives you a summary of your data. It says what is the count of data that you have per row, mean of it, the standard deviation, and mean of it, and 20%, 50%, 70%, and the max. So if we also on this, as you say, description and statistic include those that summarize the central tendency, dispersion, shape of a data set, and all these, and all of these like parameters. And these are percentiles, as we said. So the percentiles included in the output all should fall between 0 and 1. The default are these, which is like 25% of my data is less than or more than this value that I'm giving it. So these are more statistical information, and you can also read more on it here. So it's gonna describe your data frame. Just wanna show you different things you could do. So one useful is the sort values. Sort values, you do more. We have sort indices. Okay, let me show you both sort indices. So you can sort your index, which was all already sorted, but then you have the axis. axis 0 or axis 1. So axis 0 means per row, and axis 1 means per column. And then we have ascending true and ascending false. Let's actually, so my axis is 0 by default. Let's make the ascending to, just copy this, set to false. And when I set the ascending to false, it will be the opposite. So if I make this true, I want to sort it, it's going to be 1 to 18. And if I make it false, it will be the opposite. And if I change the axis, it's going to actually sort the sort the columns based on the index, which is not very meaningful for us here. So here we have also sort values. And then again, if we do, we have axis, we have ascending, and say true to false. So the same thing. So if I do that, so let's set my axis and say axis is 0, good. Let's specify the first by one. So I say by, and I would say do it for A. And it's gonna sort the values for A. You see that the indices is not now, these are not sorted. Okay, so it starts from 23, then goes 16, goes to 24. But I sorted it by column A. Okay, and then you can change this. So another one, so again, kind is quick sort. We have different sort, like multi-level sort if you want. We can go through this. I just want to show you the method, and you can go through documentation and learn more. And if any question, ask us. So we have this in place that you see a lot. In place is an important attribute, and this means that if you, so in place is false by default. Okay, but if you make this in place true, it's gonna change your data frame in place. So if I run this, so let me show you first. So if I see what is my data frame, it is sorted by index, right, from 1 to 18. But now if I say sort it by value and make the in place true, it's gonna change my whole data frame. If I run it, my data frame is now changed. It is sorted by A. Okay, so just have in mind. But if I say in place false, so it is already changed, so it has changed it. You see that it returns something for me. Okay, so just have in mind when you want to record the result of such method of data frame, you can either, so this is a return, right? You can either make a copy of it and record in another variable, or you can make the in place true and let it take effect on the same data frame. Or you can, like third option, just specify the same name for this and it's gonna overwrite it. So let me explain one time more. So here is my data frame, right? Let's say I wanna change this data frame in place. I wanna change it itself. So I say let's sort values. Actually, I say sort indexes. I'm gonna sort indices. Then I say I like this, so make it in place true. So this is gonna permanently change my data frame. Okay, now let's do it another way. So let's say, okay, now I want to source the values of my data frame by column B, but I want to keep another copy of it. I don't want to just change it in place. So I can just do df2 and put the result of this into this df2. So if I run it, now if I do df2, I see my new one. which the date is not synced, but the values are synced based on A. So, sorry, based on B. So see that it start from -3, then it goes and increase up to 397. So now DF and DF2, they have they're like separate copies based on the sort thing that we did. So then in place false means that it doesn't affect this data frame, and you can always make a copy of it by adding another variable here. But in place true means that it's gonna change this data frame itself. Okay. So this was this. Let's go and see our df head again. All good. Some stuff about selecting data in your data frame. So I can say what is my column A, what is my column B. It's gonna give it to me easily. I can also show you. I can also select rows with this and say give me from 0 to 2. Similar concept that we had for list in Python. Okay, so let's say 0 to 3. And just have in mind that negative means the last one, so -1 will be the last row. Okay, so I can here say give me if I say -3 to -1, it's gonna give me the last 2 rows. Okay, so it will be similar to tail in this case. So just have in mind, so I can do give me these two. So I can also read on this, so I'm gonna explain a bit here. So this one is the first index that you wanna read from. This one is up to which index. And if you don't specify it, it means up to last, up to whatever there is. So if I say 3 colon nothing, it means that give me the third one and whatever is the rest. Okay. Then if I want only the 3 one, the third one, I say 3 to 4, and by default this 4 is not included. So the first one is included always. So you say the 3, so 0, so this is the head, right? 0, 1, 2, 3, you get the third index, but you don't get the fourth one. So if I make this 5, you get 3 and 4. So 3 and 4, 0, 1, 2, 3, and 4. The indexes start from 0, don't forget. Okay, and another thing that is good to know is, let's say, do you want to say give me all of the values for these 2 columns, and you can use this. So if you actually do, so if you remember we used to do DFA, right? It's gonna show you this. If you actually do, instead of one string, you give it a list and say give me 2 columns, you can also get the same thing. The difference for this is that you have also control over the rows. So you say give me rows from 3 to 5. Index and class beta. Oh, I think they changed it in this Pandas edition. I think when we have daytime and things like this, it is complaining and it's not allowing me to specify both of it. But I'm gonna show you, see if they change in this version anything. So have that in mind. So this means give me all the rows. So column, when you don't have anything before and after, it means give me all the rows, and this is give me these columns that I want. And oh, actually, okay, I know what the reason is. So the reason is this is like a data frame. So if I wanna specify it by index, I have to pass a string, because I have to say give me from this index to index for the rows, and give me this for the column. So if I give it a string, it should be able to catch it. So let's say I want to say give me from 2020 0103, and then I go up to this one, maybe 2020 07 70, and let's see if it works this time. Cool. Okay, so now it is from this to this. So if I make it go from 14 to 17, so it will be, it give you the values for these indices and all these columns for your data frame. So this is when you have daytime index and you want to specify it. And you can, as always, do shift and tab to see more information about the clock. So far so good. There are like multiple ways of accessing data in data frame. I'm gonna also show you iLock. iLock is when you want to select a row by position. So let me go to, let me show the data frame again. So if you do df head, so 0 1 2 3, this is index 3. So if I do df iLock 3, it's gonna give me the third row, which is all this value, and it sends me and return me a Pandas service. And if you want to get the value something in the middle, something like this, it's very easy with iLock. So I say df iLock, I say do it like this, for example. So it's gonna give me, I'm telling it, give me from 3 to 5, 0 1 2 3 is this one, 4 and 5, and say the fifth one is not included, so these two, and then 0 to 2, so 0 1 and the 2 is not included, so it will be this part, these two. So that's what I got, right? So we can easily change it. So it's very powerful for selecting some of your data at the middle of a data frame. So you see, this is the difference between iLock and lock. That was my mistake here. So this lock here, you're specifying the indices. You have to say the index, and then you have the column, and then for the iLock, you can just pass values and let it look at it like numbers and give you a bunch of data that you need. So all good. And here I can tell you here, instead of this, you can also specify a list. So instead of this approach, you can tell it, okay, here you said 3 to 6, but I'm gonna hard code it myself and say, okay, give me 3 4 5. Instead of 0 to 4, I say, okay, give me 0 1 2 3, and it's gonna be the same result. Okay, so you pick the values that you want. So maybe you say, give me in the row, give me the first one, which will be 0, and give me the fifth one. So the fifth one will be 0 1 2 3 4. So it'll be 4. So if I do that, it's gonna give me 1 and 5. These two. And for the column, it's the same. So you have to pass like numbers here, and if I use A and J, it will be 0, and then 1 0 1 2 3 4 5 6 7 8 9, right? Because we had 10 columns. Now you have these two. Okay, I think we had a very good progress on how to create a data frame, how to slice it, view it. Next, we are going to talk about some conditional selection and how, based on different conditions, you select the data frame and change it if you need it.